All right, we're going to start on our next project right here, and what we have is an intake manifold that goes on. I know it goes on a Honda motor. I can't tell you what Honda motor it is, but it's going into a Honda motor. The Honda motor is going into a Toyota MR2, I believe. So this belongs to my friend Phil, longtime friend here in town, and Phil's got I guess I would call it a side business where he does a lot of customization on Jeeps, off-road vehicles, and then this is his own personal project. This MR2 where he's transplanting a Honda motor down in it, and so this is just something personal for him. But so anyway, what he's asked me if I could do, he bought this intake manifold off of eBay. It was he said it was one of the cheaper versions that you could buy. Fabrication looks real nice on it. All the welds look real pretty. He's done a customization right here where he cut this end off and welded a plate on there. But so what's going on is that the flange right here that mounts up to the motor is not straight. All right, it's got a little bit of a bow in it from the welding, and I don't know what process they might use, whoever builds it, to try to get it flat again. But it is warped on the ends, and he says that he couldn't get it to seal properly. So he asked me, is there a way that I could machine this face and get it nice and true? So I got to looking at it when he showed me a picture of it, and I thought, that looks like a great shaper job, honestly. And that's what I want to do. I want this to be another shaper project and utilize the shaper's capabilities and using the universal table on this. This face here is not 90 degrees square with that, so it poses a little bit of an issue with setup, depending on what kind of machine you want to use and how you want to set it up. So there's not really a whole lot to work with there because of all this custom formed body right there. Trying to get it held up in the mill, it's a little bit of a challenge, but I think I got a game plan. I think I got a plan to get this mounted up and get this cut, and I'm going to have a lot of fun with it. So let me show you what my plan is to hold it. So as I said, we're going to be doing this in the shaper, and so what I need to do is hold it like this. Okay, I want to hold it like this and then have our tool go across there and get it cut. So I want to utilize this flange here to mount it, and then we're going to have some kind of, probably like a jack out here, and maybe one or two toe clamps just to support the outer end, keep it from chattering. So I've got an angle plate right here. This angle plate here will actually mount up to this hole pattern right there nicely. So we can mount this side right there in the angle plate, and then because of the angle, you can see the angle there where it's mounted up. This side's kicked up, so we need to kind of tilt it so that this thing is going to be nice and level, get it indicated. That's where the universal table on the shaper is going to come into play. Once we get it squared up side to side this way, we can tilt the table and just simply indicate it so that this is indicating nice and straight, and then lock it in and then make our cuts. So that'll make it nice and simple right there. And I haven't got to do this kind of job on the shaper yet, and this is something I've been kind of looking forward to showing you. So a lot of you guys, are like, why not use the mill? Why not do this, do that? So let's talk about a couple other ways that you could do something like this in a conventional mill, because not everybody's got a shaper. You could do the same thing in a conventional mill if you had a tilting table that's like an angle plate, but the table actually rotates from one side to the other. So if you had one of those, you could mount this flange to a rotating angle plate and actually dial it in that way. I've got one that I've used in several jobs and showed it before, and I could mount it to that and get it leveled up that way as well. You could also do the same thing in a, let's say a horizontal mill like the K&T over there. You could mount this to an angle plate just like this. Let's see, let's go this way because we got these little fittings here. So you can mount it to an angle plate like this pretty easily. Clamp this to the mill table, and you have to do some some leveling and things like that to get this square, and then just indicate this face along the axis of the table travel there, and then use a milling cutter or a fly cutter or whatever to come across and cut that. So that would be another easy way to be able to line up with that axis of the plate is to be able to clamp it down to a mill table, just like so. So there's a couple other ways that we can do it, but I love showing you guys. I love playing with the shaper and utilizing that. So let's go over there and start getting her set up. I was going to show you the out of squareness here, just using a machinist square, and you can see just right there what we're dealing with. This is the mock setup right there. This plate right there actually come with the intake as well. He had brought that, so it served as a good spacer with the original bolts. These are 8mm, and I just spaced them out with the washers as I need. So we'll just get it bolted up just like this to the angle plate, and then we'll start tilting the table down to get our flange indicated nice and level, and then get this outer end supported with a machinist jack and a couple toe clamps. So just want to show you that's what the setup's going to look like. So now we can go to the shaper, start getting it ready. See how they finished the table? Just like I was showing on the straight edges. Using a, I don't know if they used a big planer whenever they manufactured the machine, but they cut it the same way with a high step over and a broad nose tool. And the cuts look exactly like my, my straight edges do. I need to use this spacer back there just to help space out the bolts, and this this other flange nut that I was using two there, is going to be in the way. So I think what I'm going to do, I'm just going to remove this and just use the one, and then if I need to, I might just put a toe clamp there. It may not be needed, but I'm going to go ahead and take this out, and then we'll bolt this up. All right, that should work better right there. I got the hole pattern set right. Actually, I think I got it reversed. This is sort of a odd bolt pattern here. Got to get it lined up just right. So we go through that hole. What we'll probably start with is we'll go ahead and run an indicator across this direction right here to make sure that we have it rotated this way correctly, and then get that snugged up, and then we'll get the outer end supported properly, and then start doing our indicating by rotating or tilting our table, should I say. We need to twist it around just a bit. I'm going to see if I can tap this thing around. Keep doing this until we get it squared up. It's looking pretty close right there, man. Maybe a thousandths too far. I think we're pretty good, right about there. For the outer support here, I'm going to use this planer jack. It's got a V machined in the top there, so that'll just kind of line up with the very bottom. And we've got it all the way down to the very bottom, and you see the pad swivel, so it's lining up good with that right there. And there's a weld bead underneath there, so I'm just going to kind of put that weld bead right in that little V notch. All right, just kind of push it up in there, and we've got us a toe clamp set up right here that we can use to just kind of hold the clamp, the jack in place. And I'm padding the back of it with a piece of brass. Actually, it needs to come over just a touch. What I'm doing is just kind of leveling up this pad here underneath it so it's not turned at an angle. If we can get our stud tightened up now. There we go. It's pretty good. I'll put just a little tension on the screw, just like that. I think we're pushing up on it now, so we're just going to leave it right there, and I'll see what I can do about getting a toe clamp out here to keep it just held down against that. All we really want is just to keep it from trying to vibrate, so there's not a lot of holding pressure down needed. All right, to support the outer end, I'm going to use these clamps right here. I used to use these on the boring mill when we had it at my old shop, and this is the first time I've used these tall ones since then. I think they're going to do the job just right. I got just enough height out of them. Don't need a whole lot of clamping force, just enough to secure the part down against the V-block there. All right, I think that's going to work right there. I think that's it. This is the clamp that holds the table there from tilting. We got one on the other side, so we're going to go ahead and loosen these up. We'll stick a level up here on the flange face and just kind of eyeball it with a level to get it straight, and then we'll start indicating it. We'll use my Lufkin 58 precision level here on the flange face. All right, and then we'll start rotating the table down. Got the worm screws down here, and use this square drive out here on the end. The machine is not level, so that you can only use this to kind of get you close. That's all we're doing. We're just going to use it to get our flange close, right there. So from there, we'll go ahead and start indicating. We'll just sweep it across there and just make sure that our indicator is even on both ends there. Got the stroke set now, so let's see about how far out we are from end to end. About 20, 25 thou, maybe 30 thousandths. Okay, we're still low on this end. Actually, I'm sorry, we're high on this end, so we still got to go down just a touch. Probably going to be a good spot a little bit further in from the ends because it's bowed a little out there, so we might use like these holes as our reference as to what we're going to get indicated. So about 21, 22 right there. So we got a little bit to come down. I just make little movements at a time. See if I can just work it as it's. Oh, might have went too far there. Yep. Went too far, need to go the other way. Pretty good right about there. Let's see where it's like. I think that's going to be good right there. I'm going to go ahead and lock her down. So it looks like the indicator's falling around 4 to 5 thousandths on this hole and this hole, which is evenly spaced from the ends. Let's check it again. So what, we're on about 4, 4.5. See if I can stop on this hole back there. Yeah, 4. So it looks like I hit it right where we need to be. Go ahead and grab the wrench, snug the clamp. It usually does a pretty good job of not pulling on you, these clamps. Four. Come on, baby. 4, 4.5. I think we're good to go. These are the tool bits that we're going to use today. This is the one that I just touched up right here on the grinder. It had a little bit of a burnt corner. I touched it up and then honed it real nice, so we've got a nice corner there, nice, really sharp cutting edge. Just showing the guys what the angles look like right here. So I'll use this one to get the bulk of the metal, which isn't much. You know, we're talking about 15 thousandths. And then if depending on how the finish looks with this may be good enough, but what really looks nice is a shear tool finish. Now this is my shear tool right here. I've shown this before, and although this is primarily for steel, this works really good on aluminum on a shaper. And I've got that honed, and you see what kind of helix angle you've got. So this is the I'll drop my soft gel there. So this is the direction of cut right here. Your workpieces there, and they show this in the old textbooks there on shaper uses and how to grind your tools. So we may finish it off with this, but we'll start with that tool. But I was going to show you this block. This is one that I did a while back, and I just saved it because it looks so good. So this side here I did on the K&T mill, so you can see that's a milled milled finish there. That's the milled finish on the K&T anyway. I'm sure that can be, you know, done a lot better on some other machines. This right here, let's see, this was the better side. So that is the, that's done with a shear tool right there. You see how nice that looks? That's a shear tool finish on aluminum in the shaper right there compared to the milled finish. So it doesn't really matter, it all gets the job done. This is still really smooth, but I really love the way the shear tool looks on aluminum in the shaper. 14 3/4, so we'll set a 16-inch total stroke length. Alright, so we need to adjust our tool forward. Pretty good, right up there. There's our touch off right there. So I've got the stroke set at 41 strokes a minute. Recommended speed would be 70, but that's running up there at a speed I'm not comfortable with on this shaper. So we're gonna run at 41. It'll do a good job there. All right, we're ready to roll. We've got it set at 20,000 step over. Let's see what that does. Fed it down 10,000, so it won't quite clean it up. I want to see what 10,000 looks like. Speed engaged. Looks like we could use some cutting oil on it. We got some Cat Magic for aluminum. Cat Magic helped big time. I remember that before. see, we were pretty even on our indicating. There's a low there and a low there. It's pretty well even on both sides. It definitely did better with cutting oil over here versus without, a little more etchy. So we really don't have far to go. We'll probably take 5 thousandths now and see what it looks like after a cut. I stopped the cut because it's not cleaning up out here, so we need to go down a little bit more with that. But the finish is looking real good this time around. I slowed the feed rate down and it looks nice. that's the end of our two cuts, both cuts being 10 thousandths, and in the last cut there I slowed it down to a 10 thousandth step over, which is the slowest that the table will feed there. But I actually think it looks really good, and I don't believe I'm going to do any more cutting on it. I'm not even going to worry about the shear tool, because that is a beautiful finish on there, and it cut it from end to end. It just needs cleaned up, get all that oil off of it. I think this thing is ready to roll. I don't think it needs any more cuts. I think we're going to leave it just like that. Super smooth finish on it right there. Really depends on what angle you're coming at, and you see that just sort of that weird pattern in the material, but looking at it this way, it just looks beautiful. Got that mirror finish on it. Get it out of there, and I'll finish cleaning it off real well, making sure all that tap magic is off of it. You got just a little bit of burr on it right there for making the cut, so I'm going to use my Noga here and just very lightly get rid of that little rolled over edge inside the porthole. Just like that. Well, there we go. This job's finished up. I had a lot of fun doing this, and being able to utilize that universal table for the first time for an actual real job, that's going out of the shop here. So I thought that was a very great way to use the machine. I thought the shaper did a great job. It did a beautiful job on the cuts, and I'm real happy with it. I know Phil's happy that I was able to get it done for him. Whenever he had called me, he goes, "I don't know how you're going to hold that thing," but he sent me a picture of it. I knew right away how I was going to hold it, and that's exactly how I did with the angle plate and a jack and a couple strap clamps there. If I was to do this without having a shaper in the shop, I would probably most likely go to the horizontal mill, clamp it to the angle plate just like I showed here, and then all you got to do is just kind of support this in and get this indicated in line with the axis of the table, and then run a milling cutter across it that way. I think that would be another good way to do this if you don't have a shaper. I just like using the shaper because I like a shaper, Doing it in a Bridgeport or a conventional mill is going to be a little bit more tricky, and I just don't, everybody does it, you're going to run a fly cutter across there, but it's just a much more elegant way to do it with a shaper, I think, with a single point tool going across there. You're not beating and banging and shaking this thing around with some fly cutter, coming across it with a cut. So anyway, job done. I hope you guys enjoyed watching it, enjoyed sharing it with you, and we'll see you on the next project, all right?